Hi guys, welcome to my new video on the language Scala. So Scala is one of the programming language which is like any other programming language, Java, C++, where you can build software tool out of it. Scala is very popular in the world of big data processing. Like if you consider some of the very popular tools like Spark which is built over the language Scala, or Kafka, it is built using Scala. So let's start. The agenda will be like this. We'll start introduction about Scala and we'll go with what are the feature it offers. We'll go with some examples of Hello World and some more examples. We'll go deep dive. But as part of this video, I'll try to build the foundation for Scala language and I'll come up with more videos where I'll explain more examples, more features of Scala language. So let's start. So introduction. As part of introduction, this is a language which is kind of a general purpose language. This is not only for big data technology, but it can be used in terms of building a web application or RESTful services or any kind of utility tools. This is not specific for big data, but it is good in big data processing world. It was built in 2001 by Martin Odeski. He was kind of one of the founders or founding members of the Java generic world. It is also so it is having basically features of an object-oriented programming language plus combined features of functional programming language. So it is also cross-compile language where you can compile it into bytecode which runs inside a JVM, or also you have features for compiling it into a JavaScript output also, so that you can use that whatever code you have written in a JavaScript based server or JavaScript based browser. Also, you can do it in .NET also, the output can be done in .NET. So basically the term Scala, it came from scalable language. So the founders and they had this idea of building a language which can be scalable, which is more into a multi-threading world. So that's what Scala is. So what are the features it offers is, so it is basically a functional programming language. For last video, I have explained about what exactly functional programming paradigm is and more about comparison with object-oriented programming language as well, and what are the major features of a functional programming paradigm. So you can go through my video link, the channel link, and there you can find the details about functional programming paradigm. So even Scala is purely object-oriented language. So I'll talk about that more in coming slide. And also there is a feature called type inference. How exactly type inference helps in making a Scala a good language for both prototyping as well as a large scale application. Inbuilt support for singleton also. Singleton will talk about what exactly singleton is, immutable and mutables, how you can choose between those, and also we'll go through some examples on writing expressions, what exactly expressions are. So our first feature, the purely object-oriented features of Scala. So Scala does not support primitives. Scala has only wrappers. If you go through the wrappers of Java, same you can compare here also. Here also you have boolean, char, int, float, double, and string. And instead of supporting primitive, we don't have those primitive. We have only wrappers. So the benefit here is you have utility methods over wrapper. You can use those, as well as we have benefit in terms of multi-threaded environment also. In multi-threading, primitive plays a role, and in terms of the multi-threading, if you have objects, we are safe by using object. So that I'll explain in my upcoming video, that more about how Scala handles that multi-threading things. And type inference. Type inference is one of the feature which is very nice to have in Scala. So if you talk about type inference, basically there are two types of programming language in terms of how they compile it, or how they identify the type of your object. So like one is statically typed language, another is dynamically typed language. Statically typed language are like Java, where we have to give the type of the object or type of the variable at the declaration time only. At the time of declaring variable, we should give the type always. It is compulsory. So that at compile time, that type is identified and matched, and internal things can be done. So statically typed language, it is good in terms of long-term project development. If you are building a very big application, then it is easy to maintain those kind of code so that other can come in and read your code and understand it. So that is statically typed language. And we have one more type of language, which is kind of dynamically typed language, where you don't have to give the type at compile time, but the compiler automatically identifies your type of object or type of variable or type of declaration you are making. So those are called dynamically typed language. So dynamically typed language are good in terms of prototyping or when you are doing an R&D kind of thing where you don't have time for writing a big amount of code. Instead, you want to try something at a very fast pace. So in that case, dynamically typed language is good for. Like Python is one of the language which is dynamically typed language. So these are two categories of different types of typed language. But if you combine both these features of statically typed and dynamically typed language, Scala supports both this by the help of type inference, where what it does it, you can choose between statically typed or dynamically typed. So whenever your situation is there where you want to do a prototyping, you can do a prototyping by not declaring the type, or when you want a big application to be written, you can go with statically typed case. This is handled by type inference at compile time. So there is a type inference concept which automatically identifies your type of object at compile time. So this is the benefit we have purely object-oriented programming language. This is the first feature. Second feature, instead of going into feature, let's get into some coding example, like how exactly we write code in Scala. So our hello world example, this is it will be like this. So for starting a code or for running a code in Scala, every time it has to go through an object, which is kind of singleton object. So the execution start from this object type. So here we have defined, like in Java, you have a main method. Here also we have a main method, but only difference is we don't have to declare a class. We can directly create an object of it. So by using object keyword, we can define an object which is of singleton type. So here this is the method def main args is there. This is type of input parameter. Arrays, we are saying that it is of type array and string type of array. And here in Scala we have the return type declaration like this. And unit is kind of void in terms of Java. Same alternative here we have unit. And then you can directly print that one. So the execution of this code always start from this object class where we have main method. Like in terms of Java, the execution start from main method wherever you have declared inside a class. So here we don't have to declare a class, but instead of object we have to declare, and from that execution will start. We have one more way of running that execution of the Scala code that can be done by using apps app uh, app trait is there, where we have inbuilt feature of whatever we write inside this object, that will be defined inside the main method, and that will become an executable again. So here we have again declared an object of type, but it is extending app type. It is extending app type. In that way we don't have to define this main method, and whatever you write inside that one, that will be an executable for it. So either of the approach you can choose for writing a good piece of executable code. So this is our very first example. So again, in terms of IntelliJ, you can write this and directly you can run that one by clicking on run, and it will automatically identify the main method of it. Okay, so inbuilt singleton, whatever we saw in our previous slide, this is like inbuilt singleton object was there. So object hello world demo. So this is a singleton object. So this is inbuilt in terms of Scala. In terms of Java, if you want to write a singleton object, you have to write the bigger piece of code and you have to take care of in terms of synchronize how it will work, in terms of non-synchronize how it will work, but Scala has provided it inbuilt. So what exactly singleton is? Uh, if you don't have idea about that one, this definition is that singleton is a object with a single instance over the JVM. So whenever this instance is created, that will remain in the JVM for or the lifetime of the JVM. So it will not create new instance of that particular type of class. So only a single instance that is good for creating some kind of constants. If you have like you want to define some constant set of things, then it is always not required to create a second set of constant like string. You want to declare a list of string saying that key value pair is this one and that will remain same over the lifespan of this complete JVM or every time it will be same, then you can declare constants by using this singleton class or configurations you can create. Or in terms of Spring, you have this default scope of bean is also a singleton that also you can create by using this singleton objects. So by using the object keyword, we can define singleton. So whatever we saw example in our last code was just we declared object and the object name and whatever we define inside that become the definition of that particular object. So this is inbuilt singleton support we have in Scala. So let's see how to declare class and functions in Scala. So as this is again an object-oriented programming, we have to define some class and their behavior by using functions. So here is the example. You can see that class is declared by using the class keyword and name of the class, and whatever you define inside that is called as class. In my upcoming video, I'll explain more about like how the constructor, inbuilt constructor is there, how this constructor is there. All those will be covered in my upcoming videos. So if you want to define a function, like you have declared a class, inside that you want to declare some function, then the definition can be done by using a def keyword. Def is used and the name of the function. Then what is the input parameter name? First that we declare here and the type we declared by using a colon sign. And again, the return type is also like the type declaration. So what is the return type we declare here by using the colon sign? And here we can have the type of the return value. So as I talked about type inference, this is not compulsory that we should always give the return type here, but as part of writing a good quality code or readable code, we should always go with a return type definition here. And then inside the braces, you can have the method definition and whatever there at the end. So whatever the last statement will be there in the method, that will be automatically taken as the return type of this particular function. So this way we can declare a class and function in Scala. So immutable and mutable reference. So this is one of the good feature already Scala is providing as being a functional programming language or the language which support functional programming. This is one of the good concept we have, immutable and mutable reference. So val is used to declare a final or immutable variables. So like consider a situation where you have a variable v equals to something or string s equals to my name Saurabh. So over the complete execution of this application, you don't want s to be reinitialized. You don't want the value to be modified, whatever pointing through the s variable. Then you can define it by using val keyword. So anything assigned to val type of variable cannot be modified throughout the JVM execution. You cannot modify that variable. And we have another alternative which is kind of mutable. If you want something which can be mutable like a variable t or variable temp, if you have initialized some value and over the execution of the application you want to modify that value, then you can define by using where keyword. So here we have a good concept here. So well and where is kind of combination we use in terms of writing our application. So if you define a variable with where keyword, then object state is all not final. Object state is kind of mutable. Object state is mutable and also the reference is mutable. If you define well with object, then object state is final and as well as object reference is final. So this is kind of one chart you can use for writing while writing your code. So we have another good feature which is called expression. So what exactly expression is? Basically, in terms of programming, when we write a function, what we do is we are kind of modularizing the application. We are kind of defining a separate set of behavior for that particular class in terms of a function. So function is kind of one feature or behavior you are providing. So there are some scenarios where you don't have those kind of requirement, like you don't want to declare every time a function, uh, but the requirement is very small where you don't have that requirement of defining it inside function, but only a if logic is there, which is kind of if with a variable then this do this, if with a variable then do that. If you want to make it reusable code of that if statement in terms of any other programming language, uh, like Java, what you have to do is you have to block it inside a function and make it a different function and use it. But always we don't have that much of high requirement that every time we should make a function and that should be a reusable block of code. Instead, we can define expression directly. Let's see some example on expression here. So here my GitHub is there, you can find some more examples on Scala. So what exactly expression is here, you can see that. So I have a requirement of pi expression where you have kind of uh, you want to calculate the value of pi. So whatever based on this value, it will return you this. Last statement is the kind of return from this expression. So this is a reusable piece of block we have defined, and we have not defined it as a function but as a expression. So you can see that every time when you try this one, it will try to evaluate the values of this expression. So this is kind of declaring a reusable piece of small code, not writing into a different function but directly defining by using expression. So one more example we have when we have nested scope, like again the pi is there. Inside that one more pi value is there, and whatever be at the last statement that is kind of return statement for this expression. But in terms of nested scope, here we have this value, whatever the innermost value is there, that will be return statement for this. So we can write nestable expressions also, and that can be evaluated. So this is one example. And here, if we write like in the previous statement, we didn't declare anything outside this braces. But here, when we declared this outside the braces, then this will become the return statement. So this way, we can write expression and small piece of reusable code we can write by using expression. So we have different expressions also, like the if else expression we have. Consider the case you want to declare something like this, where based on some input value, based on that some input value you want to find a condition or execute a condition. So here in terms of expression language or the language that supports expression, we are writing it like this. So if this value is not equals to 0, then do this, else do that one and return none. So none is again one of the concept which is kind of returning void, or kind of returning options in Java. So that we'll talk about in upcoming video. So this, by using this, we have defined everything inside an expression, and we can reuse it wherever we want it. So like the execution of this expression will be done inside this whenever we call it. So based on whenever you pass this or change this value, the statement expression evaluation will change. So we have if expression, we have nested scope, we have match expressions we have. So what is a match expression? So this is kind of like a switch case in terms of Java or any other language. So based on condition, what case has to be executed. Like consider this is one of the example here. So based on day of the week is one of the string value, whatever you pass here. And if that is equals to Monday, that is a string value equals to Monday, then it will return start of the week. If the value is Sunday, it will return end of the week. So this way we can write a small switch case also inside a expression, and that will be evaluated whenever you pass whatever the value you pass here, that based on that, that will be evaluated. So these are some of the example of expression, how we can use it. We have one more kind of expression like the for expression. For expression is again like in terms of Java, we have for loop, but in terms of Scala, we have expressions. So again, this kind of we are declaring a small piece of function inside a variable so that we can use this for loop wherever we want instead of writing a bigger function abstraction, we are writing it inside an expression directly. So by using eld keyword, you can make it an expression so that it will return whatever at the end of this. So whatever you are doing here, that will be returned from the this kind of piece of code. So like consider this is a list of days are there, and based on that I want to execute this one. So here is the example for days. You can see that eld is doing some kind of execution, and based on that it is returning some value. Also we have a default case. If nothing matches, then default case will be executed. So this is kind of very high level details about what are the features we have with Scala. In my upcoming video, I'll go more deep dive and more example with Scala, where we can talk about how we can deal with like for loops and how we can deal with the collection, immutable collection in terms of Scala.